right, here's problem number 2 of the free response portion of the Unit 5 review. So R is the given shaded region, and it's nice that they gave us a graph, but this is a calculator problem, so the only thing it's saving us from is graphing on our calculator, and it's clarifying that we want this region and not this other region over here, so that is important. So what we need to know, we need to find out the lower limit of integration, and we're going to have to do that by solving on our calculator. So for part A, which wants the area of our region, we know we're going to have to integrate from whatever that lower limit of integration is up through 1, and the top curve is going to be the square root of x, the bottom curve is going to be e to the negative 3x, then we have dx. So let's go to our calculator to solve for the lower limit of integration, and I'm going to do it on my graphing screen. So I'll go and I'm actually going to type in the graphs of the square root of x first, and then e to the negative 3x, and then I'll just do a zoom 6 to get a standard window. It's actually not a good idea now that I'm thinking about it, because I really only want x from 0 to 1, and then y I think from 0 to 1. So let's hone in right on this same window that they gave us, and we'll get the exact same graph. Makes our lives a little bit easier. So now if I go to F5, Math, and I want the intersection of the two curves, first curve, second curve, and then I need to go to my lower bound, way over here, and then my upper bound, over here, and I find out my intersection is at 0.2387, on and on. That's important for you to keep as many decimal places as you can. So I'll write down here 0.2387. So then in order to find this integral, I need to go to my home screen, and we will integrate. Choice 2 is integrate. And I'm integrating top curve, rad x, minus bottom curve, which is e to the negative 3x. And I'm integrating it with respect to x, and on the interval 0.2387, comma 1. Let's see what we get. I got 0.4426, which rounds to 0.443. So for full credit on the AP exam, you will have to put in your complete setup, including your limits of integration, and the answer. So next problem, we're going to find the volume when we that's generated when we revolve this around this line, the vertical or the horizontal line y equals 1. So I need to do find my big R and my little r, because this is definitely a washer method. So my big R is going to be the distance from the axis of revolution to the very outermost part of the region. And big R is always top minus bottom, so 1 minus e to the negative 3x. Little r is also always top minus bottom, so this time is 1 minus the square root of x. So then, when I revolve my region, I have the same limits of integration I had in part A, and then my big R is going to be 1 minus e to the negative 3x all squared, minus little r of 1 minus rad x all squared. So now the trick is going to be to get all of that in our calculator accurately. Okay, so I'm going to start by just putting in my big R expression. So 1 minus e to the negative 3x, and I will go ahead and square this. Make sure I got it in right. I always check the left hand to get the actual input, and that is correct. Now let's put in our little r, so 1 minus square root of x, square that whole expression, check the left hand to make sure your input is correct, and it is. So now let's go ahead and integrate. Choice 2, let's choose our big R squared, minusing out our little r squared with respect to x, And then on the limits of integration, 0.2387 through 1, close paren, and then multiply by pi. And it's going to think for a moment. And I get 1.424, which is the correct answer. And I can just go up here and check by scrolling to make sure I typed it in correctly, which I did. And I should put my answer actually down here as 1.423 or 1.424. And again, for these calculator problems, show your setup and your answer. So the last question on this problem is, the region R is the base of a solid. Each cross-section perpendicular to the x-axis, which basically just means up and down instead of sideways. We have a rectangle whose height is 5 times the length in the region, whose base is in the region. So the region, the base of each rectangle, is just top curve minus bottom curve. So same limits of integration, 0.2837 to 1, top curve minus bottom curve, so rad x minus e to the negative 3x. You're going to square that because it's really this times itself times 5 to get that length of the rectangle. So once again, we're going to evaluate this in our calculator. And one of the reasons I love the TI-89 is that I can scroll all the way up to the very first time I plugged in top minus bottom, pull it into my line, and then I'm just going to go back. Actually, I need to clear that row. I had too much stuff in there. Go back up to the very first time I integrated top minus bottom, pull it into the line, and then we're going to go clean this up to now square the integrand and put a 5 out in front of the integral. So here, parentheses around the entire integrand and square it. And now we just let our calculator do the thinking. And we come up with the answer 1.554, which is in fact the correct answer. And once again, all we needed to show was the setup and the answer for this problem.